All right, so let's wrap this up. So we just did this. We were at location 2. So we set R equal to 6. And then we print A, B, and C. So we're inside of F, this innermost call to F at the top of our stack. So we don't have an A, B, or C in F, so we follow the static link all the way down to A, where we find A, B, and C. So we can go ahead and print out those values. So I'm going to write this. I'm just going to write this here. So the values are 4, 5, and 1. So we get output 4, 5, and 1. So that's going to be the output from this print here. And then we return R, which means that we will copy R's value, which is 6, into the return value. Okay, and at this point, that second call to F has terminated. So at this point, we start to unwind the stack. We will probably want to save the return value here. So that was, remember, this call here. So this is the 6. So we'll take note of that. And then we need to think about what needs to happen on the stack to unwind this call to F. So basically everything in this stack frame right here is going to go away. And we need to use the information that's in that stack frame to unwind things. So we are going to revert the base pointer to pointing to its previous value. And this is another use for the dynamic link. So even you'll notice that this was a statically scoped language, which means we didn't use the dynamic links in order to do name resolution, but they are still useful because they allow us to set up or to restore the old base pointer when a function returns. So the old base pointer is essentially the dynamic link. And so when we clear this up, we can move the stack pointer to point back down to, or sorry, not the stack pointer, the environment pointer or the base pointer will be pointing back to the dynamic link from the function that's returning. And then this whole thing goes away. So let me just go ahead and draw that graphically. So everything that was in the stack frame for F will go away. That second call to F. So let me. So I'm not going to be able to do this as cleanly as I would like, but we'll try to. All right, and then the stack pointer is always going to point at the top of the stack, so that'll move back down to there. Okay, so this is what the stack will look like after this call to F right here terminates. Okay, so we are still in F. So we need to finish executing what's going on here. So remember that we saved this value of 5 for evaluating B here. So now we're doing 5 plus 6, which is 11. So that's going to set this R to 11. And then once we finish with that evaluation, so we can go ahead and erase that. So now we're going to print ABC again. And it's going to be the same values, essentially, because we're going to use the static link for name resolution, and that'll go down to here where we see A, B, and C, which have not changed since the last time we printed them out. So they are still going to be 4, 5, and 1, respectively. And then we're going to return R, again in F. So that means that the return value is now 11. And so now we need to do the same step of unraveling the stack. And here, now we can look back at where this call happened, and we can find that if we lost track of it, we can find that by looking at the return address, right? That tells us where we go back to. And so we go back to line 19. So here's line 19, and this is that call to F. And so we now know that its return value is going to be 11. So that is the value that we're going to use right here. So this is going to be R equals 11 plus A. Well, we don't have an A inside of G. Well, actually, so let's go ahead and clean up that function call. So we got 11 out of that. So again, we can reset the environment pointer or the base pointer using the dynamic link of the function that is returning. So that means that this is now going to be, this is now going to be the environment pointer or the base pointer. Now everything in this stack frame goes away. As does that stack pointer, because that's because the stack pointer is always pointing at the top of the stack. So that is now going to be pointing there. All right, still a little bit to clean up here. Ooh, nice. Okay, so now we have gotten back to line 19. So we're right here. We determined that this call to F had a return value of 11. So we're now going to take that and add A. So there is no A in G. So we use the static link to go down and find A, which is little a, which is big A's 4. So we've got 11 plus 4, which is going to be 15. So that means that the assignment to the local value variable r inside of G is going to be 15. And then at this point, we can clear up those values. And we're now done executing in G. We just need to save the value of r as the return value. And now we can return from G, which means that we'll go back to line 26, which is going to put us back down here. And we determined that the return value of G is 15. So this is the value that we're going to use here. And we can go ahead and clean up that stack frame because we have used it. And that function is done, which means that that reference to C goes away. We would have used the dynamic pointer, which is, or the dynamic link, which is what this was, what this little remaining bit of arrow is representing. So now I can get rid of that as well. So that was, so this is now the environment pointer, the base pointer. And again, the stack pointer always points at the top of the stack. And this is no longer having any reference to it, so I'll just redraw that. All right, so this is what the stack looks like after we return from G. So we know that we're going to set A to 15. So that is now going to get rid of this value here and set it to 15. And now we can get rid of that over there. All right, so then we execute this print statement. So print A, B, C. We are in big A, which means that we do find A, B, and C locally. So it's going to be 15, 5, and 1. So that is the next output, and I believe that is the last output, because now we are going to return from A. So notice that A didn't have a return value, so we don't need to worry about that. So we're just going to go back to line 31, which is where we called A. And at this point, we are going to get rid of the activation record for A. And we get all the way back to the beginning, where this is now the environment pointer or the base pointer, and then the stack pointer is always pointing at the top of the stack. So we have now gotten back to here. There's nothing else to do in P, and so at this point, the program can terminate. And so at that point, everything that is over here would go away, and the program would be done. So this is then the output for the program.